Hello, grade 12s. In this video, we are going to look at Western Cape Education Departments, Metro Central Education Districts, Grade 12 Physical Sciences, Paper 1, June 2025. Question 8, which is electric circuits. So now it reads, the circuit below shows a battery with an EMF 4 volts and an unknown internal resistance. So voltmeter V1 is connected across the battery and voltmeter V2 is connected across the unknown resistor, which is this one here. All right. So the ammeter A1 and A2 and the connecting wires have negligible resistance. Now, they say to us, write down the reading on V1, on voltmeter V1 when the switch is open. So when the switch is opened, the reading, you're going to have readings across the component to be zero with the exception of the battery. So the battery has an EMF of 4 volts. So when the switch is opened, only the battery will have the reading, and that is going to be the 4 volts. So we are therefore going to say it's going to be 4 volts. So 4 volts. Now switch X1 is now closed, and the reading on A2 reads 0.4. Now this A2 reads 0.4. And the reading on V1 decreases by 0.4. So now this decreases by 0.4. So if it decreases by 0.4, that means we shall have 3.6 remaining. All right. So now let's see what the question demands us to do. It says calculate the reading on the ammeter A1. Calculate the reading on the ammeter A1. All right. Now, before we answer these questions, let's just analyze certain things here. The battery has what we call the EMF, and that is the maximum amount of energy supplied by the battery per unit coulomb passing through it, or per unit charge passing through it. So the EMF of the battery is given by E, which is equal to, now we have what is called a V external plus V internal, which is the V lost. So this plus that give us the EMF. That is before the switch is closed. And now the EMF was 4 volts. The EMF was 4 volts. But when the switch was closed, the EMF was decreased by 0.4. Now, to calculate our V external, that is what when the switch is on, then that means we have to transpose this to the other side to subtract to get this to be 3.6. Yeah, and therefore to calculate this V external, we have to say the current multiplied by the external resistance. And to calculate this V internal, we have to say the current multiplied by the internal resistance. So therefore, the EMF can also be written as the current, bracket open, V external plus V internal. So R external plus R internal. So that is the formula for the EMF. So let's move on to the question. All right. So now back to the question. The question says we should calculate the reading on A1. So the reading on A1. Now we know that the A1 is the total current. So the current travels, when the switch is closed, it travels towards this direction. But when the current reaches this point here, it has two pathways to travel. Some of the current goes through these two resistors, and the other goes through this 3 ohm resistor. So the two current meet, and the total current will travel through this unknown resistance. So if I know the current that goes through the 4 and the 2, then added to the current that goes through the 3 ohm resistor, that gives me the total current. And when resistors are in parallel, they have the same voltage across. The voltage across them is the same. The voltage across them is the same. Okay, so we call the resistance in parallel currents, we call them current divider. And in series, we call them potential divider, because the sum of the individual potential difference in series is equal to the total potential difference. Okay, total external potential difference. So now let's see, how are we going to calculate the current across the 4 and the 2 ohm resistor, which added up to give us 6. To do that, we first of all need to know what is the voltage across the 3 ohm resistor. And we can do that because we were given the current here to be 0.4. So if that is the case, we shall say that that is 2.8.2.1. All right. So to calculate the voltage across the 3 ohm resistor, we shall say that the current now times the resistance. So what is the current? The current is therefore equal to 0.4. That is the current across that resistor here, times that resistor, which is 3. So when I multiply these two, I'm going to get 1.2. So this is the voltage across. So the voltage across this resistor here is the same voltage across these two resistors. Therefore, I can say the voltage across the 4 ohm plus 2 ohm, which is the 6 ohm resistor, will therefore be equal to, now, the current. Okay, the voltage across that, I'm now going to find, now the current, I know what you call, the voltage across the two is the same. So if they have the same voltage, the voltage across this will also be equal to 1.2. So if I know the voltage across the 6 ohm resistor, that is these two added together, then I can say the current across the 6 ohm resistor is therefore equal to the voltage over the resistance. So now the voltage is 1.2 and that resistor is 6. So if I have to work this out, I am going to get 0.2 amperes. So that is the current across those two 4 ohm plus 2 ohm resistor. So now I can say my A, which is the total current, is therefore 0.4 plus 0.2, which is equal to 0.6. That is my total current. All right. Also, there is also another way which I see it to be easy to calculate the current that goes through the 6 ohm resistor, that is the 4 ohm plus the 2 ohm resistor. Okay, now in terms of ratio, we know the currents and the resistance, they are inversely proportional. So if I have 6, these two, if I add them, I get 6. So if I say 6 ohm resistor is to now 3 ohm resistor, I'm just doing another way to find the currents that goes through that 4 plus 2 ohm resistor. Now I am giving the current here to be 0.4. So if the current here is 0.4, right, 6 is to 2, 6 is to 3 is just like 2 is to 1, right? So the currents and the resistance are inversely proportional. So the bigger the current, the smaller the resistance. And the smaller the current, the bigger the resistance. So they are inversely proportional. Okay. So therefore, I need to ask myself, if 3 ohm has the current of 0.4, now the 6 ohm, am I going to have a bigger or a smaller current? I'm going to have a smaller current. Therefore, I have to take the 3 over 6 times 0.4. Now this gives me 0.2. So if that is the case, then the current here is 0.2. Therefore, I can add those two currents to get that 0.6. All right, so now we know the current that goes through that part, which is the total current, which is 0.6. Let's move on to the next question. Okay, the next question says, we should calculate the resistance of resistor X, this resistance here. So to calculate that resistance, whenever we have to calculate resistance, that is 8.2.2. Whenever we are calculating resistance, we just have to say the voltage over the currents. But now, how do we find the voltage across that resistor? So we therefore have to say the voltage across the X resistance is equal to, now the total external voltage is 3.6. That is what we got here. When we subtracted, we got 3.6. That is the total external voltage. And we got the parallel side. We got the voltage across the parallel side. We got it to be 1.2 voltage from our calculation. So this voltage plus this voltage here give us this voltage. Okay, so when we subtract, all right, this voltage, we take this out. From that, we're going to get this part. All right, so now let's see what the voltage is going to give us. We're just going to subtract 1.2. So therefore, the voltage across the X ohm resistor is going to be 2.4 volts. That is the voltage across the X ohm resistor. So therefore, how do we find the X ohm resistor? How do we find that resistance? We're going to say the X ohm resistor is now equal to the voltage, which is 2.4. And then we divide 2.4 by, okay, we divide, sorry, by here, I made a mistake here to say the resistance again, so it's supposed to be the currents. All right, and the current. So now we divide by the current, and the total current goes through that, okay? Because we explained that when the current reaches this side here, they join together, so the total current passes through this resistance here. So now this is what I'm going to do, and this would give me the magnitude of it is going to be, now let me see, let me use my calculator. Oh, it's going to give me a perfect number, which is 4 ohm resistor. So that is how to find the resistance, the unknown resistor. Now they say to us, I should find what you call the internal resistance. Okay, so the internal resistance, that is question number. Let me just erase this part. All right, so now I'm going to find the internal resistance, that is 8.2.3. So the internal resistance, if I have to use the formula EMF is equal to I R plus R, then what is my EMF? I know my EMF to be 4. And what is my current? It was 0.6. So what is my external resistance? So my external resistance, I have to therefore calculate the resistance in parallel, add to the resistance in series. So I have 1 over Rp, which is equal to 1 over 6 plus 1 over 4. Yes, the 2 of this gives me 6, and then this is 3. Sorry, here is 3, I wrote 4. My mistake. All right, so 3. So now if I have to use my calculator, here I'm just going to get the Rp to be equal to 2 ohm resistance. So that means the total external resistance is going to be 2 ohm plus the 4 ohm that we got this side. So which is going to give us 6 plus R. Now what do? All we have to do is we shall have to divide, right? Divide 4 by 0 points. We're going to divide 4 by what you call 0.6 and then subtract this from that. So all I am going to do is that I'm going to say 4 divided by 0.6, and then I'm going to take the 6 also over. So to say minus 6 is equal to my R. So therefore my R is going to be 0.67 ohms. That is my internal resistance. So now that is all about 8.2.3. So now the next question says, the 3 ohm resistor is now replaced with a conducting wire of negligible resistance. How will the reading on V1 change? Write down, increase, decrease, or remain the same. So now V1, we're going to go to V1. This is our V1 here, right? So what we have done is this 3 ohm resistor has now been replaced with a wire of negligible resistance. So, okay, okay, so now we are going to take away this part. Okay, this part is now replaced by a wire of negligible resistance. That means there is no more resistance, no more resistance. So what will happen here is that now the flow of the current is going to now go through this, is going to bypass this side, is not going to travel through this resistance because it would like to travel where we have less resistance, because what the resistance does is that now the resistance opposes the flow of the electric current. So if this part has no resistance or is replaced by a wire which has a negligible resistance, then it will like to pass through there. So this is going to be the resistance of the circuit. It's not going to travel through these parts. So if that is the case, then the total resistance is going to decrease. And when the total resistance decreases, now we are therefore going to state that they say we should state whether the voltmeter, the V1 is going to increase, decrease, or remain the same. So now, one thing that I want you to know is that whenever the resistance, the external resistance, whenever the external resistance decreases, right, the total currents will increase, because current and resistance, they are inversely proportional. And then the V internal, which is given by this, it will also increase. And the V external, which is given by this, it will now decrease. So you can see that this current and the V internal, they go in the same direction, and this and that also go in the same direction. V external, that is the V1. So we therefore say that the V is going to, that is 8.3, is going to decrease. So why? What is our explanation? We now going to state that the total external resistance. So the total external resistance decreases. And total currents increases. All right. So now the R, this R here, it's what? Increases. So this, the V internal or the V lost, we are going to say the V lost, or we also call it the internal increase. And since the R remain constant, increases, okay, since R is constant, Okay, so now from the equation, E is equal to now V external plus V internal of V lost. Yes. Yeah. From this equation, if we have this to increase, what will happen to that? So this is constant, this is constant. So this is the R is constant. So if the R is constant and the current increases, this R here, the R is constant. So when the current increases, it increases whatever is here. So we can therefore state that V external, therefore, V external decreases. So that's all about this question.